Okay, class, so today we're going to continue our discussion of quadrilaterals by talking about rectangles today. And these are very similar to parallelograms. In fact, rectangles are types of parallelograms. There's just one or two key differences. And just like a parallelogram, we'll start off. Both pairs of opposite sides are parallel, and opposite sides are congruent. So again, AB is going to be congruent to CD. It's also going to be parallel to CD. And at the same time, AC is going to be parallel to BD. And it's going to be congruent to BD. Okay, so just like yesterday, our opposite sides are parallel and congruent. Okay? The one key difference with rectangles is that all four angles are right angles. So A is a right angle, B is a right angle, C is a right angle, D is a right angle. They all equal 90 degrees. In a parallelogram, they don't have to be congruent, but in a rectangle, all four have to be right angles. Okay? And then once again, since they're all right angles, that means consecutive angles are supplementary. And so A is consecutive with C, so A plus C is 180. A is also consecutive with B, so A plus B is 180. And you can say the same thing about BD and CD. We have four sets of consecutive angles that are supplementary, that add up to 180. Okay, so now class we're going to talk about the diagonals in our rectangle. And once again, we can create two diagonals here. We have CB and we have AD. Now the main difference between a parallelogram and a rectangle is that in a rectangle the diagonals are congruent. So in a parallelogram they weren't necessarily congruent. In this one they are congruent. There's a big reason why. And just like yesterday, we are going to go ahead and draw these triangles that we've kind of created with our diagonals. So we'll make triangle CBD. I need to go ahead and group that together. So there's triangle CBD. And then I'm going to make another one with the other diagonal, ADC. ADC. Okay? And we'll group that one together as well so you can see that relationship they have here. These two triangles are congruent. And the reason is because since this angle is 90 and this angle is 90, the sides that they point to must also be congruent. That's a part of hinge theorem, which we talked about last week in chapter 5. So because the angles are congruent here, that means my two diagonals are going to be congruent. AD is equal to CB. Okay? Now the second thing that's different between rectangles and parallelograms is since my diagonals are congruent, when they bisect each other, all four pieces are going to also be congruent. So AE is going to be congruent to CE, is going to be congruent to ED, is going to be congruent to EB. All four of them are going to be congruent. And one more thing we didn't talk about with parallelogram, and it is still true with parallelogram, is the relationship between our angles that have been formed by our diagonals. Okay, so for example, and I kind of like to use fun shapes here. So we're going to start with a little star. So if I have put my star right here, I also have the exact same angle down here. We call that relationship alternate interior angles. Okay, but if you notice, what kind of triangle have we just created down here? We now have an isosceles triangle. So if this is a star, guess what? We've got another star over here because it's an isosceles triangle. And if this is an isosceles triangle, then this star means we're going to have another one here. So those four angles are congruent. At the same time, we have another set of alternate interior angles. We have an angle here that is an alternate interior angle with this one as well. They are congruent. And again, because of isosceles triangles here, This angle has to be the same as this one, and this angle has to be the same as this one. So alternate interior angles are congruent. We'll do some practice problems tomorrow in class.